Right now, as you listen to these words, trillions of electrons inside your brain are spinning. Your heart is beating in sync with a planet that rotates at over 1,000 miles per hour. And that planet orbits a star that spirals through a galaxy, spinning once every 230 million years. Everything you are is caught in a dance of rotation, so ancient and so vast that it connects you to the first moment the universe began to turn. This is not a metaphor. This is physics. We are taught to think of the universe as a stage, a static backdrop where things move across it. But that is an illusion born from the limits of our perception. The truth is far stranger and far more beautiful. The universe is not a stage at all. It is an infinite turning engine. Rotation is not something that happens in the universe. Rotation is the universe. From the spiral arms of distant galaxies to the quantum spin of invisible particles, from the slow waltz of black holes to the frantic dance of electrons in your cells, everything, everywhere is spinning. And the deeper we look, the more profound the mystery becomes. How did this begin? What law demands that motion, not stillness, be the fundamental truth of existence? And most crucially, how are the vast cosmic scales connected to the quantum realm, where particles obey rules that seem to defy logic itself? Tonight, we journey backward through creation. We start with what we can see: the turning galaxies, the orbiting planets, the rotating stars and trace that motion inward, deeper and deeper, until we reach the quantum foam at the heart of reality itself. There, in that realm of probability and spin, we will discover that the universe's greatest secret is also its simplest. Everything turns because, at the very beginning, something had to break perfect symmetry, and from that first tiny rotation, all else followed. You were about to learn why nothing in the cosmos can ever truly be still. In the darkness of space, far from any cooling planetary surface, in regions where the universe reveals itself most nakedly, there exists a state of matter that dominates the cosmos. It is the state we rarely encounter in everyday life, yet it comprises over 99% of all visible matter in creation. This state is plasma, ionized gas, atoms and molecules stripped of their electrons, leaving behind positively charged ions and clouds of freely moving charged particles suspended in electromagnetic fields. Plasma fills the hearts of stars. Plasma streams outward from the sun at velocities exceeding 400 kilometers per second. Plasma fills the immense voids between galaxies. And plasma, everywhere it exists throughout the universe, rotates. This rotation is not random molecular agitation. This is not simple convection or passive diffusion. This is organized, directional motion, a fundamental characteristic of plasma itself. In laboratory settings, when physicists confine plasma using powerful magnetic fields, in tokamak fusion reactors, where they attempt to harness nuclear fusion, or in stellarators designed with complex three-dimensional geometries, the plasma does not sit passively within its magnetic cage. The plasma spirals. It rotates around magnetic field lines. It develops internal shear flows where different layers move at different speeds relative to one another, creating turbulent whirls and electromagnetic instabilities. The plasma moves. The plasma turns. The plasma spins. This rotation arises from several intertwined physical principles working in concert. Magnetic fields, threading through the plasma, constrain the motion of charged particles along specific curved paths. An electron, or ion, cannot move freely through space in the presence of a strong magnetic field. Instead, it follows a helical trajectory, gyrating around magnetic field lines while simultaneously drifting perpendicular to those lines. These gyrations are rotational by their very nature. Pressure gradients within the plasma create differential rotation, the outer layers of a plasma column moving at different speeds than the inner layers, generating shear and turbulence. When a mass of plasma begins to collapse under gravity, conservation of angular momentum dictates that it must spin faster as it compresses, much as an ice skater spins faster when drawing their arms inward. Plasma, at its most fundamental level, is a medium that naturally organizes itself into rotation, given even the slightest initial asymmetry or pre-existing spin. Consider a collapsing cloud of plasma in the depths of space. Gravity pulls inward. The cloud compresses. As it compresses, if that cloud possessed even a tiny initial rotation, perhaps one rotation per million years, the conservation of angular momentum forces that rotation to accelerate dramatically. The cloud flattens as it spins faster. Material that was moving slowly now whirls at tremendous velocity. The infalling plasma does not plunge directly toward the center, but instead organizes itself into a rotating disk structure. This is the fundamental geometry of gravitational collapse in the presence of rotation. The rotation is not a peripheral detail. The rotation is the organizing principle that determines the entire structure that emerges. This principle, born from plasma physics in the depths of space, extends outward to shape the largest structures in the universe. When vast clouds of primordial hydrogen and helium plasma began to collapse in the earliest epochs of cosmic history, billions of years after the Big Bang, when the universe had cooled enough for gravity to dominate over radiation pressure, these clouds did not collapse symmetrically. They did not fall inward uniformly from all directions. They rotated. The plasma organized itself into rotating structures. As these structures collapsed further, the rotation accelerated. The clouds flattened into thin disks. And within these rotating disks, the first stars ignited, and the first galaxies took shape. The Andromeda Galaxy, the grand spiral visible to the naked eye on clear nights, is a rotating mass of plasma and matter so immense that light requires 2.5 million years to traverse from one side to the other. Yet it rotates. It completes one full revolution approximately every 250 million years. The Milky Way, our own galaxy, rotates once every 230 to 250 million years. These are not rapid rotations by any everyday measure, yet they are real. Billions upon billions of stars, along with vast clouds of gas, dust, and the mysterious dark matter that gravitationally dominates galactic structure, all move together in coordinated rotational motion around the galactic center. The spiral arms visible in photographs of galaxies are not rigid structures like the arms of a pinwheel. They are rotating density waves, regions where gas clouds pile up and compress, triggering waves of star formation as plasma collapses into stellar furnaces. This organized cosmic rotation carries information. It carries memory. It encodes the history of the universe itself. In the first incomprehensibly brief fraction of a second after the Big Bang, in a period lasting perhaps 10 to the power minus seconds, the universe underwent exponential expansion called inflation. During this epoch, quantum fluctuations at scales far smaller than atoms were stretched by the expanding universe to cosmic proportions. These fluctuations were not uniformly distributed. They carried directional asymmetries. They encoded seeds of rotation. As the universe continued to expand and cool over billions of years, gravity began its patient work of pulling matter toward regions of slightly higher density. Primordial gas clouds inherited the rotational biases encoded in those ancient quantum fluctuations planted during inflation. As these protogalactic clouds collapsed under their own gravitational attraction, conservation of angular momentum forced them to spin faster. The slow, barely perceptible rotation of the primordial plasma cloud became the rapid, organized spin we observe in galaxies today. The plasma clouds flattened into thin rotating disks. The disks became galaxies. The rotation that began in quantum fluctuations manifested at the largest observable scales. Webb has observed galaxies existing less than 400 million years after the Big Bang. Galaxies formed when the universe was merely 3% of its current age. And even these ancient systems already display organized rotation and spiral structure. Astronomers expected to find chaotic, disordered systems at such extreme distances and such early epochs in cosmos. Instead, they discovered that rotation appears almost immediately. This finding suggests that the rotational seeds planted by quantum fluctuations during inflation were remarkably effective at organizing primordial plasma into the spinning structures we observe today. Within these rotating galactic disks, new and equally remarkable processes unfold. Vast clouds of hydrogen plasma and helium accumulate in denser regions throughout the galactic plane. These molecular clouds begin to collapse under gravity. As billions upon billions of metric tons of plasma compress inward, the cloud must conserve its angular momentum. The rotation accelerates. A cloud that possessed barely perceptible spin begins to rotate rapidly, faster and faster as it collapses. The infalling plasma does not plunge directly to the center. Instead, it organizes itself into an accretion disk, a rotating disk of material spiraling inward, following mathematical curves dictated by gravity and angular momentum conservation. The disk rotates fastest near its center and more slowly at its outer edges. This differential rotation generates turbulence. It amplifies magnetic fields threading through the plasma. Through magnetic braking and viscous processes, material gradually loses angular momentum and spirals inward toward the forming center. At the core, temperatures and pressures reach millions of degrees. Hydrogen nuclei begin to fuse together, releasing vast quantities of energy. A star is born. This star emerges not in isolation, but surrounded by the rotating accretion disk from which it formed. Not all material in that disk has reached the star. Some material retains sufficient angular momentum to orbit at a distance. This orbiting material, still contained within the rotating disk, undergoes further gravitational fragmentation. Denser regions accumulate more plasma over millions of years. These regions coalesce into planets. The planets inherit the rotational motion of their parent disk. They orbit their star in the same rotational direction as the disk spins. Most planets also rotate individually, spinning on their axes as they orbit. The planets of our solar system all orbit the Sun in the same direction, and most rotate in that same direction, all sharing a common inheritance from the rotating protoplanetary disk that existed 4.6 billion years ago. The Sun itself rotates once approximately every 27 days at its equator, though its poles rotate more slowly, a phenomenon called differential rotation, a remnant of that original rotating plasma cloud. The planets carry this rotational heritage as well. Earth's axial tilt and rotation define our day and our seasons. Jupiter rotates once every 10 hours, spinning so rapidly that it cannot maintain a perfectly spherical shape, bulging outward at its equator and flattening at the poles. Saturn's rings themselves exist because of the equilibrium between that planet's gravity and its rapid rotation. The moon's orbiting planets orbit in the rotational plane defined by their parent planet's spin. The entire architecture of planetary systems flows from the rotation that emerges when plasma collapses under gravity. Yet the descent into smaller scales does not end at planets. It continues inward, deeper, into realms that challenge our everyday intuition and require us to abandon classical mechanics for the strange and precise calculus of quantum mechanics. Deep within atoms, within the very substance of matter itself, rotation persists. But here the nature of rotation transforms into something that cannot be visualized in classical terms. Electrons possess what physicists call spin, an intrinsic form of angular momentum that has no classical analog. An electron does not literally spin on its axis like a miniature planet or star. Spin is a purely quantum phenomenon, a property that emerges from the deep structure of space-time and quantum fields themselves. Yet electrons exhibit quantized spin values, specifically spin up or spin down, representing two discrete orientations of intrinsic angular momentum. There is no in-between, no partial spin, no continuous range of values, only discrete quantum states. These spin states form the foundation of atomic structure. The Pauli exclusion principle, the rule that no two electrons can occupy the identical quantum state, emerges fundamentally from electron spin. The structure of the periodic table, the properties of elements, the chemistry that makes life possible, the very atoms comprising your body, all of these emerge from electron spin and the organizational principles it imposes on matter. Photons, the particles of light that carry electromagnetic radiation across the cosmos, possess spin 1. This spin manifests as polarization, the direction in which the electric and magnetic fields oscillate as light propagates through space. Quarks, the fundamental constituents of protons and neutrons, possess spin 1/2. Higgs bosons have spin 0. This quantization of angular momentum, this fundamental restriction to discrete, specific values, is one of the defining characteristics of the quantum realm and reveals that rotation is not merely a large-scale phenomenon, but something woven into the very fabric of quantum reality itself. What unites these disparate phenomena across every conceivable scale of existence? The rotation of galaxies spanning millions of light years, the rotation of stars and planets across thousands and millions of kilometers, and the intrinsic spin of electrons, occupying spaces billions of times smaller than a grain of sand, is a principle so fundamental that it may reflect something profound about the nature of reality itself. This principle is the conservation of angular momentum. In any isolated system, the total angular momentum cannot change without external forces acting upon it. This conservation law is not arbitrary. It emerges from a deeper mathematical principle discovered by mathematician Emmy Noether, the fact that the laws of physics are identical, regardless of the orientation or direction we adopt in space. This rotational symmetry of the laws of nature, this fundamental indifference to which direction we call up or down or left or right, mathematically guarantees that angular momentum must be conserved. A law discovered through the study of spinning objects on human scales, the rotation of wheels and tops in celestial bodies, applies with equal precision to the quantum realm, where intuition dissolves into probability waves and quantum fields. An electron spin follows the same mathematical conservation principles that govern galactic rotation. The universe operates according to unified laws that transcend scale, that connect the infinitesimally small to the incomprehensibly vast. Plasma rotates according to these laws. Stars form from rotating plasma. Planets orbit in rotating disks. Electrons spin with intrinsic angular momentum governed by the same conservation principles. This is not coincidence. This is not accident. This is the deep order underlying creation. Yet this raises the most fundamental question of all. If conservation of angular momentum requires that rotation persist and that spinning systems spin faster as they collapse, then we must ask, what gave the universe its initial rotation? What cosmic accident or fundamental necessity made spin the organizing principle of reality? How did a Big Bang, an event of perfect symmetry, with no preferred direction, no reason to rotate at all, produce a universe dominated by rotation at every scale from galaxies to atoms?